Hi and welcome back to our Lemonade tutorial series. In this part, we are going to look at how to interact with objects. Right now, our bee can fly around and respond to keyboard input, but it can't really do anything else yet. What we want to add next is some interactivity. Specifically, we're going to spawn apples randomly in the sky so they fall down, and the bee will try to catch them. If the bee isn't fast enough, the apples will just fall past it. So this will be our first small step into working with physics. But first, let's take a quick step back to the last tutorial because we forgot something important. Let me pull up the code from last time. You might remember that this update method in the bee controller gets called 60 times per second. Well, that's technically true, but only if your machine is rendering at 60 FPS. In reality, update is tied to the frame rate. So if you're at 120 Hz or your GPU is struggling, it might run much faster or slower. And that would mean, since we're using a fixed value for movement speed, the bee would fly faster or slower depending on how powerful your computer is. That's obviously not what we want. To fix this, we need to compensate for those timing differences. So we'll add a few values at the top of the script along with some comments. You can find the script in the description below. Feel free to copy and paste it or pause the video to type it in by yourself. We're going to use a small variable called delta time ms, which stores the number of milliseconds that have passed since the last update. Ideally, that's always 1000 divided by 60, but in practice it might vary. To adjust for that, we create a new variable called speed adjustment, which calculates how far off we are from our ideal 60 FPS. Then we multiply our bee's movement speed with that adjustment to get a consistent result. Now, when I hit play, you won't notice any difference. My computer runs at a stable 60 FPS. But on a slower or faster machine, this would prevent the bee from speeding up or slowing down unexpectedly. Next, let's focus on spawning new objects. This is something we'll need to do often, so we're going to set it up in a reusable script. I'm going to attach it to the floor entity, click Add Script, create a new one, and call it Spawn Controller. Now let's paste it in a basic template and go through it line by line. You'll notice that a few new fields appeared on the right after pasting the code. These were added using the add property method. That method comes from the entity class, so any entity can use it. It takes at least two parameters, a name like spawn object and a type, which can be node, number, boolean or string. In our case, we are using node and number. Number creates a field where we can enter a numeric value. Node lets us drag and drop another object into the field. For example, I can drag the background object into it, and then our code will have access to that object. It can move it, change it, or even delete it. We'll later use this to define what kind of object we want to spawn. The other fields define the area in which we want to spawn objects. Area min XYZ and area max XYZ. These 6 values basically define a 3D box in space where spawning can happen. Frequency controls how often a new object is created. If we set it to 1, that means 1 object per second. Now let's dive into the update function. We add a time threshold ms, which defines how many milliseconds should pass between spawns, and a time past ms, which keeps track of the time since the last spawn. On every update, we add the delta time to time past ms. And if the past time exceeds our threshold, we subtract the threshold and spawn a new object. This means we also need to define the time past ms variable in the script. Next up, the spawn method. Here we use Lua's math random function and give it to our min and max values for the x, y and z axis. This generates a random position within the defined area. We then use the clone method on the spawn object to create a new copy of it. At the end of the clone call, there's a next function. This is triggered once the cloning is finished. Cloning can take some time depending on the object, so this is where we finalize things. Inside that function, we simply call setActiveTrue on the new object. Why? Because our reference object in the scene is deactivated. We don't want it visible at the start. But when we clone it, the clone inherits that inactive state, so we have to explicitly activate it. Before we test it, we need to set up some values. Even though some defaults are pre-filled, they might not be very useful. Most importantly, we don't yet have a spawn object. Let's create a new mesh. Go to the asset store and grab an apple. I'll place it up here in the scene, but we don't want it visible at the start. So we drag it into the spawn object slot and deactivate it. Now it's hidden just like we want. When we run the game now, we'll see apples spawning in the sky. But nothing happens when the bee touches them. They are just falling objects for now. We should at least make sure they fall properly and spawn from a consistent height. We go back to the script and set both min and max Y positions to 1. That way they all spawn from height 1. Alrighty, let's test it. Yep, now they all fall from the same height. Great. Now let's add gravity. Click on the apple and enable physics. The default values are fine. But wait, now they're falling for the floor. That's an easy fix for us. Click on the floor, enable physics there too. Make sure its mass is 0. That makes it a static object, meaning it won't move but can still collide with other objects. And let's try it again. Much better. Nice. Some apples still fall through the gaps between floor tiles, but that's okay. Eventually they'll either hit the ground or be caught by the bee, and in both cases we're gonna make them despawn. One last detail I want to point out. We activate the clone after creating it, because the original is disabled. If we didn't do that, the clone would stay invisible too. In the next tutorial, we'll move on to handling collisions, either with the ground or with the bee. But ideally, I don't want the apple to just hit the ground. I want the bee to catch them. So we'll need to figure out 1, when do we actually catch an apple? And 2, when does it just fall past us? We'll cover all that up in the next episode. Stay tuned!